Okay, so I'm solving the chapter 2 problem number 39 on page 49. So the question is, a student throws a set of keys vertically upward to her sorority sister, who is in a window 4 meters above. The keys are caught 1.5 seconds later by the sister's outstretched hand. So the first part is, with what initial velocity were the keys thrown? And the second part is, what was the velocity of the keys just before they were caught? So first I drew my diagram, just right here. So as you can see, this is the girl throwing the keys, and there's the keys, and there's the sorority sister waiting 4 meters above. So I made this part 0 where the keys are, and I made this direction positive. So for A, I wrote out all my givens, so we don't know what the final velocity is, and we're looking for the initial velocity. We know what the time is, which is 1.5 seconds, and we know the acceleration, which is negative 9.8 meters per second squared. And we know the displacement is 4 meters. So because the displacement is 4 meters, that means it can go up and then come right back down because the displacement doesn't change. She's only 4 meters above. So then we're going to solve this problem using this formula, which is the displacement equals initial velocity times time plus half of the acceleration times time squared. We plug in all of our knowns, and we just have this variable right here, and then we use simple algebra and solve for the initial velocity, which we get as 10.02 meters per second. Then for part B, we're finding the velocity of the keys just before they were caught. So when they are caught, the velocity is 0, but we're trying to find it right before they're caught, so we don't know we're looking for the final velocity, which is what we're looking for. We know the initial because we just solved it, and the time is the same along with the acceleration and the displacement. And we're going to use this simple formula, final velocity equals initial velocity plus acceleration times time. We plug in all of our knowns, and then we solve for the final velocity, which is negative 4.68 meters per second squared. And this also helps prove that the diagram here, that it goes up and then comes right back down, because right before the sorority sister catches the keys, it's going at it has a negative velocity, which means it's going downwards. So that's problem number 39. Thank you so much for listening.